Hey everyone, and welcome to Pod 4 Journal Club. This is where we break down some of the most fascinating new research papers out there. Today, we're looking at a paper that asks a really critical question. Have we been grading AI all wrong, especially when it comes to math? The answer, it turns out, might just change how we think about artificial intelligence itself.
So let's just jump right in with that big question. Think about it. What if an AI gets a math problem right, but the way we're scoring it is so rigid, so inflexible, that it gets marked as wrong anyway? Well, this paper suggests that's exactly what's been happening, a lot more than you might think. To really wrap your head around this, just picture two different referees. The old way is kind of like this super strict robot referee. It only accepts one single, perfectly formatted answer. Anything else is wrong. The new way, which is what these researchers are proposing, is more like a smart AI judge, one that actually understands the context and the meaning behind an answer.
So just how bad is this old way of grading? How flawed are we talking? Well, the researchers dug up some examples that are honestly pretty shocking. They really show you the scale of the problem.
Okay, so take a look at this. It's a pretty straightforward word problem, right? Something you'd see on a standard test. It's asking for the latest time Jordan can start baking. And the AI gives its answer, 2 p.m. Now, to you, to me, to any person, that looks perfectly correct. But just watch what happens when our old system gets a hold of it. And boom, fail. The old system, our robot referee, marks it as a failure. Why? You're not going to believe this. It's because the official answer key was just the number 2. The system was so rigid it couldn't figure out that 2 p.m. is the exact same thing in this context. This isn't a math failure, it's a formatting failure.
Now you might be thinking, okay, that's a simple example. But believe me, it gets even worse when you move on to more complex science and math, like this question here asking to compute a star's luminosity.
So the AI does all the hard math and gives the answer in a super common scientific notation, 4.5 times 10 to the power of 33. This is completely standard stuff in physics and astronomy.
And yet again, it's marked as a fail. The old system was expecting 4.5e33, and it just couldn't recognize that 4.5 times 10 cubed 33 is mathematically the exact same thing. The AI did all the hard science right and got failed on a technicality. It's crazy!
And this problem is absolutely everywhere. We see the old system failing AIs for using different variable names, like x instead of n, or for using totally normal derivative notations, or even for tiny, completely acceptable differences in decimal precision. All of these are correct answers, just getting tossed in the trash.
Okay, so the scorecard is clearly broken, but the great thing is, the researchers didn't just point out the problem, they actually decided to build a better one. It was time to fire the robot referee and hire a much smarter judge.
And the approach they came up with is called LLM-as-a-judge. The idea is actually pretty simple, but also really powerful. You use a very advanced AI, a large language model that understands language and context, and you have it grade the answers from the AI you're testing. It's basically like asking an expert professor to check a student's homework instead of just using a rigid answer key. So here's the game plan. It's a clever 3-step process. First, to make sure it's not biased, the judge AI solves the problem all by itself. Then, it checks its own answer against the official one from the dataset to create a kind of verified solution. And finally, armed with all that knowledge, it can fairly and accurately evaluate the answer from the AI being tested. So, what happens when this new, smarter judge actually starts grading the exams? Well, this is where things get really interesting. The results are nothing short of a game changer. Just look at this chart. We're looking at the super tough Minerva math dataset. That dashed line way down at the bottom, that's the score from our old robot referee. Now look at that solid line way up top. That's the score from the new AI judge. The AI score almost doubled. That huge gap between the lines represents all the correct answers that were just being thrown out before. And get this, in one specific case, a model that we thought had an accuracy of about 35% with the old method, while with the new, fairer grading, its real accuracy was revealed to be over 65%. That is a mind-blowing 30-point jump just from grading it properly. And this wasn't some one-off fluke either. The researchers saw this across other standard datasets too, like the grade school math problems in GSM8K. You see the same pattern again and again. The new evaluation method consistently shows that these models are way more capable than we thought. They even did what's called a meta-evaluation, which basically means they graded the graders themselves to see how accurate they were. The results speak for themselves. The old rigid method,
was only about 74% accurate at telling if an answer was right or wrong. The new LLM-as-a-judge, it scored an incredible 97% accuracy. But of course, no new method is ever perfect, right? And the researchers are really transparent and upfront about the limitations of this new approach. It's not a silver bullet.
So you got to keep a few things in mind. First off, using a powerful AI as a judge is more expensive and it's slower. Also, the quality of the grading really depends on how good the judge AI itself is, and it still needs the model being tested to put its final answer in a nice, neat box so it can be parsed.
So you might be wondering, why does any of this matter? Okay, so we give AIs a better grade, so what? Well, this has some really profound implications that go way beyond just test scores. It gets to the heart of how we build and train these systems. As the authors themselves put it so well, you can't improve what you can't measure. If your ruler is broken, you're never going to build anything straight. Having a reliable yardstick is just absolutely fundamental to making any real progress.
And this, right here, is the key takeaway. A better scorecard doesn't just give us a more accurate snapshot, it actually lets us train AI more effectively. This is especially critical for advanced techniques like reinforcement learning, where an AI basically learns from getting rewards for correct actions. If you're rewarding the wrong things, the AI can't learn properly. Getting that feedback right is everything.
So this whole thing leaves us with one last, huge, open-ended question. For years, we've been using a broken ruler to measure one of AI's most important skills. And it just makes you wonder, what else are we measuring incorrectly? What other hidden abilities might AI have that we just haven't been able to see yet?